Welcome to 2025. Okay, well, it is October. It's been 2025 for a while, but let's just assume this is welcome to 2025 and my Nix systems overview, how I'm managing my stuff, and some thoughts for how you should manage your stuff, which really comes down to one thing: is Nix flakes are great. Sure, there are legitimate concerns with them or whatever, but Nix flakes are great. There's not many systems that let you do what you can with Nix flakes and define how you want it for your system, cross-cutting concerns across, multiple computers, multiple software systems, multiple builds and or applications, and do it in a way where you can place your business concerns front and center. They're not hidden behind some multiple layers of abstraction in some Terraform library somewhere else. You can put it right top and center. That is really unique across systems. I can't think of off the top of my head another mechanism by which you can define these cross-cutting concerns and distribute it as a library that other people can consume. Yeah, Nix flakes, they're freaking awesome. They're great. Definitely use them. Let's add to the ecosystem. The more, the merrier. We could finally break down the Nix packages monolith. Fantastic stuff. So how do I use Nix flakes in managing my system? Well, I actually use it via deploy RS. Deploy RS, as it says, simple multi-profile Nix flake deploy tool. Last time I did one of these videos, I was using Colmena. And the big reason I switched from Colmena to Deploy RS is the Nix flake support. So Deploy RS has much of the same value as Colmena had. Stateless, so I don't have to maintain a database or anything like that. Pretty simple. It's just a command with some various options for how I want to deploy or build things. The API, again, offers some of the value of Colmena, where we're able to define in our Nix code our NixOS configurations for some system, along with all the other stuff that a flake can define about what it's in that repo, which includes stuff like modules, other packages, library functions for the Nix ecosystem, all distributable in a Nix flake. Really have had a great time with Deploy RS, getting it to do what I want. That said, I instead have put a library on top of Deploy RS that really structures it how I want to use it for ease of development in the particular case of adding to Nix packages or other Nix flakes that I'm using in my system configuration, making it easy to develop on those and test those changes effectively. All of it is just some abstractions over Deploy RS implemented in Nix. And we can see what this looks like here as just a short preview, and it's very similar to Deploy RS using this library. We import the library, we build our flake using the Nix configs library, and we define our systems right there. So this is really just adding some structure on top of Deploy RS. And this is the library, Nix configs. Used to be my full configs, but I have actually split those out into my own repository separate from that library that just contains my home lab configuration. And we'll check this out to see what an actual use of that library looks like. This is the flake.nix, my home lab using that Nix configs library. Again, that Nix configs library is an abstraction over Deploy RS. So what do we have here as our start of our flake is the inputs. I'm importing the Nix configs library that I use, setting some inputs there to track the branches of Nix configs I want. And I'll talk more about this Nix configs unstable and why I like that. Then I add other inputs for other Nix flakes that I'm using. That's all fairly standard Nix flake stuff. The next part of the flake is the output, which in this case, I'm again using my Nix configs lib make flake to define the flake. And for me, when I'm talking about a flake of systems, I'm really just interested in the systems, any modules that might be associated with that, and the Nix flakes that I'm developing as I'm working on that flake. So let's start with the systems. This should look pretty familiar if you've seen any of the Nix ops or Colmena videos I had or overviews there. This is the physical network of systems that are in my home lab. I really like NixOps's system of separating the logical from the physical. And you'll notice that these don't reference directly a configuration or anything like that. It's just the name and what type of architecture they are. I do have two other systems that don't fall under that standard configuration. One of them is an installer ISO. This is the NixOS installer, just with additional settings and configurations and packages that I want bundled with an installer when I get a new computer. For instance, this has some SSH setup. Then there's the Raspberry Pi image that I use. So where are the configs for these if, I'm just defining the systems here? The Nix configs library enforces that all computers, unless you set the config path, have a folder under the name computers where the name matches this attribute name here, which is also my local host name for those. So we can see deny has a folder deny, GLONASS has a folder GLONASS, so on and so forth. GLONASS is my primary desktop, and we can go ahead and look in here to see what the default looks like. And this is pretty standard for my computers, what I like to define for each of them without using Nix modules. I break this up into references to hardware parts, my network authorization and authentication domain it's attached to, and then generally broken up by audio, file systems, memory, and GPU. You don't have to break it up that way. There's no requirement with this Nix configs library to do that. That's just how I like to do it. This default, typically the only thing I want in this default, and I'm not too strict on this, but is enable and disable of modules. Typically these are things I'm testing before I move them into modules that kind of capture the purpose behind those changes. Like right here, you can see that I have some system packages in there, and it's not really clear why I'm including those system packages. So in that case, I would move this to a module and name the module something semantically meaningful, like developer base or a desktop or such like that. But all my computers follow this, which means for me to add a new computer to my system, I add it here, I give it its folder, and that's about it. I'm gonna check out a simpler one here. Actually, let's go to Thrash is a simpler one. Again, same idea, referencing the hardware, network, authentication, authorization domain, file systems, audio, GPU. And then here I am referencing another Flake's NixOS modules. So you noted in my Flake, let's go ahead and pull that back up here. I have a Flake I'm depending on called RetroNix, which just sets up RetroArch as a single automatically logged in desktop, which is nice for like a console-like experience. And we can see that I can reference that Flake here and then pull in that Flake's modules here. Nice and modular. I like that quite a bit. It lets me split my OS configuration, my NixOS modules, across multiple Flakes, have them compose predictably. And you'll note I also do something here where I tell RetroNix to follow my Nix package's input. Really slick thing about Flakes is I don't need to do this, right? Like I don't need to have RetroNix, which includes RetroArch, like I mentioned, follow the Nix packages input that I'm talking about here, which is my branch of Nix packages. If I didn't do this, whoops, let's go to the other one. If I didn't do this, then RetroNix would build against whatever Nix packages it referenced in its Flake, which might be what I want. That might be the latest stable that it works with. And there's no problem at all where I have, RetroNix following one branch of Nix packages, getting that complete tree, that entire closure of all the software it needs at the version it specifies, while having other software use different versions of Nix packages. And it works. It's great. I wish I could do something like this in other systems, but yeah, that's pretty handy. One thing you'll note is that I am referencing some modules that are non-standard NixOS modules. These are part of this Home Hive Flake, the desktop module and the developer base module. These aren't part of Nix configs, they're part of my Home Hive Flake. And I didn't really explicitly say in this flake.nix that I want those modules available. That's added by Nix configs library. What it does is it looks for a folder in the flake that is referencing Nix configs called modules, and it's also looking for another one called defaults in addition to the computers one. Defaults I'm probably going to remove, so I'm not really going to touch it. I think modules is just the better way to do it, and you have more controllability there. But we'll check out the modules, and pretty much what you'd expect is that the default file here just imports a bunch of modules. I do reference other modules that I depend on in other flakes here as well. And these about work what you'd expect. Like this one just bundles together some settings for enabling foreign binary emulation on my computer, so I don't really need to worry about the architecture too much about the programs I'm running. I think from other OSs, this might be a surprising statement because you're like, oh, well, you need wherever it's referencing a foreign binary to make sure you have the foreign binary libraries it needs, whatever, stuff like that. It doesn't really matter, if these foreign binaries are referencing stuff under the NixOS store, it's only going to be referencing the ones that are relevant to that architecture. Yeah, so I highly recommend using NixOS if you want to do multi-architecture stuff. But that's the idea, is that I have modules in here that I might want to turn on or turn off from my computer configs. And that's part of what, the Nix configs flake gets you. Again, this is largely just an abstraction over deploy RS. But there's a particular structure I want, and there's a particular amount of development support I want for the flakes that I'm actively working. And that's what's referenced here, dev flakes. The dev flakes option of Nix configs is totally an option. I'd imagine that if I was just using this to manage my systems and I didn't really care about developing the flakes that I'm using to implement my systems, then I wouldn't really. However, in this case, I do want to develop on Nix packages and some of the other flakes here as I'm working on my computer, so I can rapidly test those changes in my full system. If you're familiar, this is what a flake lock file looks like. This is defining for all the input flakes what SHA or version I am referencing for those. This flake.lock file represents the production build of my home lab. Production sounds fancy, but it's really just like the stable build. It's what my computers are usually running, and it's what is built by deploy RS when you just do Nix build. That finished building, and we'll check out the result here. That is the standard deploy RS build, like I mentioned. And at the top here, we're going to have each one of our computers with their top levels there, which I can examine if I want. I mentioned that prod build is what I primarily have Nix configs library there to support. And yeah, when I do Nix build, it just uses the Nix flake and the Nix flake.lock for everything. However, if we check out the dev shell menu here, and the Nix configs library sets up dev shell with these commands, we'll see we have our standard deploy RS, like I mentioned, just the standard command. But we also have a bunch of dev hyphen shortcuts here. These are abstractions over either Nix build or deploy, which all do one particular thing, and that is use the submodules under dev for the Nix flake inputs. And we can see that I have submodules for Sway GNOME, Retro Nix, Nix packages, and NixOS hardware. These are the Nix flakes that I'm typically working on in terms of development, and I want to track those as Git submodules. I think Git submodules is a talk all on its own. It really is an effective way to track other source code at a specific version. And for what I'm doing is I'm tracking the development branches for these flakes. I mentioned that prod builds and Nix build just use the flake.lock, but when I use these dev commands, it's going to override those flake inputs to point to those submodules. That's what's being referenced in these command help here with dev flake inputs. That just means that it's overriding the inputs with those dev flakes, which are those submodules under the dev folder for things that use Nix configs lib. And we see some pretty standard commands here, which would probably look very familiar. Dev apply, that's your standard deploy command. Dev boot, that's deploy, but set it to switch to that on next boot. Dev build just does the specific top level or all top levels. That's what we just ran here with this next build dot. That is equivalent to prod build with nothing, and it's just going to build one particular, it's going to build the whole top level. That's exactly the same as that next build dot. But I could have it build a specific computer's top level if I'm only working on one computer at that time. It's pretty handy because this evaluating derivation step can take a very long time with all those inputs, overrides, and trying to build all of the computers. I would like to optimize that. I really don't know how to approach that, but that would be nice. Let me see, it's completed that build, so we'll check out what the result was. Oh, sorry, this was production build. I put the production build under .gc roots to retain those build artifacts for longer time than the normal Nix GC. Result is just for the dev ones. So that's if I want to build a single computer's top level, is I use dev build or prod build with that computer name. Dev build computer package builds a specific package from a specific computer's top level configuration. You can have very specific build configuration for one computer versus another. The most obvious change between one computer and another might be architecture, but you know, it's NixOS and Nix packages. You can override anything you want pretty much as deep in the stack as you want. So building one package for one computer might involve some very specific configuration for that one computer. And I like being able to easily build that specific package for that specific computer with that full set of dependencies all configured appropriately. Let me see here, we built NordPass for GLONASS, which is just some desktop password manager. So we'll go back to this menu of options here and continue our way through. Build self package, that's just building a package defined by the flake itself with the dev flake inputs. I'm going to skip talking about these later ones here. That's part of integrating changes. First, talk about them and how they work for the prod ones. And again, this prod is largely just a mnemonic over standard Nix and Nix build and deploy commands. It's really the dev ones that use that submodules and override the inputs. Prod is just to keep a consistency in command format between development and production builds. You'll note that they're mirrors of each other and they do the thing they say on the tin for those respective build configurations. So what does prod update, Nix packages do? That's just doing flake update Nix packages. That's it. However, if I was to do dev update Nix packages, it's going to update my submodule. But you can see they're very different commands, but they try to do the same thing, but one for production being the Nix flake.lock and the other one with the submodules. So that's the general idea behind why I wanted this particular configuration, is to have that reflection between my dev builds, which are using submodules, and my prod builds, which are using the flake. We'll go ahead and build a specific computer here. In this case, I'm building the GLONASS system configuration top level, but using the dev input flakes. Now we see here where it's applying those input overrides to point to my submodules versus the flake.lock. And you notice it's not updating the flake.lock. The flake.lock is still going to be the stable production builds for all my stuff. This is just a transient development build using this specific checkout that I'm working on. Maybe I'm changing some deep level configuration of Mesa because I want to try out some patch somebody has. I don't want to apply that to my production system, but I do want to build everything. So this gives me a very easy route to do so. And there we go. We have that built. And like I mentioned, this is going to be placed under the result, which is your transient Nix build result. And this is the top level for GLONASS, but built using my development submodule. Okay, so that's the primary thing that Nix configs does. There's a few other things I want to touch on that I think are nice for how one might do a Nix OS system. I might make these into modules because they're probably a bit opinionated, but I think it's worthwhile touching it. So this sets your flake registry to track the flake inputs for your flake that is using the Nix configs library. So in this case, what this is saying is that the registry that I'm making use of should track this Nix packages input here, Nix configs input here, Nix OS input here, retro Nix Wayno, blah, blah, blah. And what that means is when I'm at my computer here and I'm like, oh, you know, no Nix profile list, this is, oh, I guess I have nothing installed on this profile, but this is what my local profile has installed on it. And when I reference a flake to install something new into the profile, in which case, I don't know, let's do lsof, no, iotop. I'm going to use that next. Whoops. Let's actually install instead of just reference it. It's already had it available, so that wasn't very exciting. But what it did when we referenced Nix packages, it didn't reference the standard Nix packages registry. What it's referencing is the actual Nix packages checkout I was using for that build of this computer, which means when I do this Nix profile install Nix packages, blah, 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 it's installing exactly the IO top that would be from this input to my flake. Not, you know, whatever the latest might be or some other branch of Nix packages. And that's where this Nix packages unstable comes from, or what motivates that. So this Nix packages, you know, that's being used to build a lot of my system. I do want a level of stability there that for some applications does not matter. If we were split out into Nix flakes with functional purposes, we wouldn't really have this problem because we could just do update of a specific Nix flake that we're interested in and not worry about this monolith Nix packages. But in this case, I find it very effective. So I have Nix packages tracking my stable branch of Nix packages and Nix packages unstable, always tracking Nix packages master. And this is pretty easy to update. You know, I do, as part of my home lab flake that's referencing Nix configs, I say, hey, update Nix packages unstable. I don't need to worry about this having too big of an impact because there's only very few things that reference this. It's really just my profile. And in this case, since that is used by the flake, the dir-env setup that I have here will reevaluate that in case there was some updates to the dev shell. In this case, there wasn't. But what I did there, this Nix flake update Nix packages unstable, that's exactly the same, like I mentioned, as Nix packages prod update Nix packages unstable. Same command, just given that alias to make it consistent with the dev one and continue this theme of prod and dev being their own sets of parallel commands. So once I, apply this to my computer, and this would be equivalent to deploy rs apply one specific computer using my production flake.lock for what the versions of everything is. And then after a very long while, we get our deployment to GLONASS and using the flake.lock. Now, if I was to use the Nix packages unstable to install something into my profile, it doesn't like me doing one on top of the other from different flakes. That makes perfect sense. So we'll go ahead and do that. Now this IO top is from Nix packages unstable. And that's generally the route that I use for keeping my Nix profile up to date. I would like to try to use Home Manager, I think. I haven't tried setting that up. I think that's the next thing I would work on for my Nix configs. That said, I don't want to spend too much time on this. It's usually just what I use to make my other software, and that's really when I spend my time. I'm pretty happy with this setup. Hopefully you found it interesting. Definitely check out my Nix configs library if you're interested. But really, The big thing I wanted you to take away from this is that Nix flakes are really good and somewhat unique in their capacity to define these cross-cutting concerns effectively. If I was to build a company or a large system these days, greenfield, it doesn't even need to be greenfield, but if I just had the leeway and impetus to do it, I would use flakes for setting up the dev environments and doing the builds. Absolutely everything. There's no real reason in my mind not to, except for how long some things take in this case. You missed it with the power of editing, but some of those builds and the Nix derivation evaluations took minutes. I'm generally working on other stuff during that. I'm in no rush most of the time for my home lab to do things, but it is worth keeping in mind. I think that wraps it up for a tour of how I'm building my home lab these days using Nix OS and Deploy RS. Generally really happy with the setup I have nowadays. I think it does everything I've been looking for, aside from maybe home manager integration, but pretty happy with how easy it is for me to iterate on flakes and then integrate them into my home lab and still have a stable system if I want by just falling back on the flake.lock. And all of this is really thanks to flakes and the flexible module that they represent for software in systems. Hope you found this interesting. Maybe you learned something. I'll leave the links to the various repos down below and hopefully talk to you later.